All right, so now we're ready to get down to the meat and bones of the course, the main thing we're looking at. And I said in a previous video, programming is about problem solving. So we're going to take an in-depth look here at what's entailed in problem solving. I guess first off is a word I've already used a couple times, and it's going to show up in homework and quizzes here at the beginning, which almost makes it seem like a subtle, small topic in here, but this word right here, algorithm. An algorithm is the steps for solving a problem. I'll read that out. Steps for solving a problem. So, an algorithm specifically is the steps for solving a problem. Our entire course here is about problem solving. So this isn't a small subtopic inside of it. This is what the entire course is about, really. This entire semester, what we're doing is learning to produce good algorithms. And that's something that will continue to improve over time. And it's going to take a little practice. It might get a little frustrating at first because we don't think in the same way a computer processes. So we have to make some adjustments along the way. And an algorithm is the steps that are needed to solve a problem, or in our case, it's going to be for writing a program. And when we put together our algorithms, we have to be very explicit. We have to include every single step, right? For example, to write these words on the board, you can't just say write the words on the board. Not until that has been defined as an algorithm, right? So make things like pick up a piece of chalk. Well, let's pick up a piece of chalk, right? Standing there is like walk over to the chalkboard. Go ahead and take that one for granted so this eventually gets somewhere. Extend right arm, move to the right location, right? And close fingers around the piece of chalk. Then move hand to the chalkboard and move it around to the right. Well, left a couple steps out there because I forgot to reorient my hand. Okay. Reorient the hand so the chalk is towards the board. And now we're big words. Wow, that's an odd way. That feels odd writing that way. But every little detail needs to be explicitly spelled out in an algorithm. And that's kind of what this whole course is about. Just learning to develop algorithms. And getting started on that, because as you progress over time, some of you might be doing things where you're going to use lots of algorithms. And as you do it more and more, it's going to improve. Like any other skill, as you do it more, it's going to improve. So we're just kind of getting a start here. And I just wanted to express that that's not a subtopic in our course. This is basically what this course is about, developing algorithms. So let's look at some of the things about problem solving, some general points about problem solving so we can get into that. I'll erase the board real quick. This definition is important. Steps for solving a problem. Make sure you remember that because the definition of an algorithm is definitely going to be quiz and then midterm and then final questions. So that's an important one. So I'm going to erase this and we'll get started into problem solving. So what does it take to solve a problem? Right? That could be a lengthy question, a lengthy answer. It could go on and on. And that question leads to more questions. But a lot of people have thought very hard about this already. So we don't have to start from scratch when we go to answer that question. And in particular, where we want to start out when answering that question is something called the four constructs. So these are like the structures that we need to solve a problem in a very generalized way. So the first one is sequential. And this video is going to be about these 4 constructs. So we're going to talk about each one in detail. So sequential, there's an order that it needs to happen in, a sequence for it to go through. The second will be selection. A way to make choices along the way. Some sort of selection structure to make so that choices can be made and alternative pathways through a sequence can be taken to eventually arrive at the solution for the problem. Our third construct is reiteration. And again, I can talk about these in detail, but ways to repeat things as needed, some repetitiveness as needed to do the step, kind of do the steps again, because we don't want to do the exact same steps again, right? The example I always use is mowing the yard. Right? You got to push mower out and you mow down the strip. So this is going to be the difference between the word repeat and reiterate. Because repeat would be to do the same thing again. Get the push mower, mow that same strip. And once again, mow the same strip. So repeating, we would never get the yard mowed. But reiteration, reiterate, that is going to be repetition with variance. So some slight changes as we repeat things. So that example, grab the push mower, mow a strip of the yard, then turn around, move over, and mow the next strip. You know, a slight variance to our repetition. And that's how things eventually get done. And the last of our 4 constructs is invocation. I spelled that wrong. It has a C with the H in invocation. Sorry about that. One of those words when we take the shorter form, invoke has a K, but invocation is with a C. And that invocation refers to we need a structure that allows us to jump out of our order and come back to it. You know, a way to leave and come back. So these 4 constructs are enough to solve any problem, right? No matter what the problem is. So maybe you're watching TV with a couple of your friends and you go to the kitchen to get drinks. It's a problem that can be solved with the 4 constructs. The sequence is, during a commercial break or whatever, you're going to stand up, walk to the kitchen, get glasses out of the cabinet. Well, there's some reiteration because maybe there's 3 of your friends over there watching TV with you. You have to get glasses down 4 times and get everybody a drink. Selection, well, which glasses are being chose, open the fridge. Maybe somebody wants water, somebody wants soda, some with ice, some without ice. Those selection options. Invocation in that example might be somebody back in the living room changes their mind and like, oh yeah, give me a soda instead of water. So you have to step out of your sequence, listen to what they're saying, then come back to where you were to finish filling up the drinks. But those structures, that's the generalized version that can be used to solve any problem. And any problem, right? The big famous one, the solution to world peace. The solution to world peace will be put together with these 4 constructs. It's just nobody's figured out the right sequence or choices to make in order for that particular one to happen. But let's kind of go through these one at a time here, starting with sequential. So what we're going to do here is analyze something in terms of these 4 constructs. And this is what you want to do in order to get better at developing algorithms. Obviously, for lecture purposes, we're going to go through it in a lot of detail. So you're probably not going to go through it in this much detail. This is just, kind of walking through the steps. But it's something you'll want to do twice in all your programs. Once when you're designing your algorithm, as you move from the brainstorming design phase, the one that's always spoofed in Hollywood, the writer sitting in a room with wadded up pieces of paper scattered everywhere. Don't skip that step. That is an important one. There's reasons why that shows up. Uh, but that all the brainstorming, putting thoughts together. But as we move from that phase into actually putting the algorithm together, you're going to want to think about these. And then afterwards, especially at this point, it's good to reflect back on it. Look at the code as what worked with it, or when you're fixing problems, but what didn't work, and think about these. And what went wrong if it didn't work, or think about what went right when the program did work. Once the program finally worked. So we're going to spell it out in the steps, but details for the lecture. But while you're doing that, that's something rattling around in the back of your mind as you go through the steps. But maybe at least here at the beginning, keep it to the foreground, and then as you do it more and more, it's going to move further and further back in the mind so that you don't have to focus on it, and that it'll help you to develop better algorithms. So to go through these today, we use that program we wrote for the first discussion board, the introduction thing. And back to our primary picture here. So our primary picture for this semester, I mentioned it a couple times already, inputs and outputs, and then coming into this class, you hopefully at least knew the computers took input, did stuff, we did outputs, and then we're filling in this part. And on that first discussion board, we filled out a couple parts. Most of our constructs for that one were us, but we'll move these into the computer throughout the semester so that the computer does more and more work. But analyzing this in terms of our 4 constructs, a lot of it is stuff we did, such as our input. That was something that was invoked, right? Because our input to get that going was we hit the run button. So starting with sequence, well, that was kind of what we did, because as it was running, we set up a bunch of variables over in RAM. So once we hit run, the computer did that. Then we set up several of them. So there's our reiteration, right? It was all us doing it, but we put our name. In the example, I did name, my age, the town I live in, but kind of varied that slight variance on repeating that set up the variables. So there's the reiteration. And also some selection, right? What pieces do I want to include in the introduction about myself? So at this point, most of these are still things we did. The invocation, right? You probably didn't name yourself. So you invoked something your parents did, right? Your parents gave you a name. And you invoked that in order to store it in memory here. Just kind of a quick analysis of what we did using the 4 constructs and to see how they go together and different ways to take them. Because again, these are very general. So we want to find the specific things we did and relate them to that as we learn about them. Then our mostly sequence here, once we had all our variables stored, the reiteration to do a few of them, selection, choosing which ones we're doing, invocation to wherever those things came from, right? Invoking our previous choices on where to live, our parents' choices on what our name is, that sort of thing. We got all that set up. Then our sequence continued to the output, which in that first example just printed to the screen. But that was our first little program there, and this is how the 4 constructs relate as we analyze that. So take a little bit of time to do that. And like I was saying, focus on it at first here with some of the small ones, and as we put algorithms together, and then again in reflection on once it finally works, and get used to these. And then as you do it more and more, it's going to move from the foreground of your mind further and further to the background, and then it just happens there. But you might want to start with it being aware and make sure you kind of do this every time to help generalize the process of problem solving, because that's what we're working on this semester, and putting together algorithms. Yeah, and so you can see all of these applied in that simple introduction discussion board program. We have our sequence, selection, reiteration, and invocation. Well, we were doing those, but as the semester progresses, we're going to move those into the computer so that there's less work for us and more work for the computer. The machines don't mind doing lots of work. But that's kind of a quick analysis on that little discussion board to show how these go together. Well, you've heard me say it before, and you will hear me say it again. Hopefully you're hearing it, watching these videos and stuff. But this is a very active subject. Programming, software development is a very active subject. We're going to learn by doing it. So now that we've talked about this, it's time to learn by doing it. So one of the assignments this week is setting up algorithms. And, please don't just rush through that, right? There's a reason that's like the core of this, that's the core content of this course. So please put some effort into it. It'll pay off later. So as you put those together, maybe pick one of your regular actions throughout your day. Go to the kitchen, make a sandwich, do some laundry. It's one of your regular actions, and have a piece of paper or a little notebook or something with you, and write down all the steps in terms of this as you're going through it, and keep track of it, and put the algorithm together. And once you have that algorithm together, ask yourself, or think about this picture. If you took that algorithm you wrote and stuck that in this picture for the situation of, like, say, a robot, would the robot successfully carry out the task? Because that's what I'm going to look at when I grade it. I'm going to think about a robot and go ahead and assume all the mechanical pieces are going to work, and that robot is going to get through the task without a malfunction. And then I'm going to look at that algorithm telling that robot what to do. And will the robot make it all the way through the task and get everything done, right? Or is it going to get stuck along the way because you forgot to tell it how to open the door and get in the kitchen? Is it going to mess up washing clothes because you didn't move from the laundry basket to the washing machine? So when you said pick up and then drop the clothes, they got dropped right back in the laundry basket and not in the washing machine to get clean. Things like that. So think about this picture with the output being the movement of a robot. Will your algorithm make that robot carry out the task successfully? Because that is how I'm going to look at it when I grade it. And, as you go through some of your daily routines, have a piece of paper and write down the steps in explicit detail that you're going through to do it, and kind of put algorithms together for those. The practice will pay off because that is the core concept of this class. So, and we have lots of other things we need to do, so the homework's going to move on from that. So here at the beginning, please put that extra attention into algorithms just to get a good start, right? Like I was saying a second ago, it's all in the foreground right now, and you're focusing on every little detail, but as you do it more and more, it's going to move further and further and further back in the mind until you're not hardly even thinking about that part. You just think about what you want to get done, and then all that stuff, you know how to do it in the back of your mind, and it just comes together nicely. But first here, please focus on it and put the effort into it, because those assignments, they're not trivial ones. That's the focus on our core concept for this semester. And as you put it together, just think about this picture and the output being a robot moving, because that is what I'm going to think about when I grade it, to see if your algorithm works.